Okay, I'm going to work through problem number 7 from the quiz. This particular problem was about the technique of dimensional analysis, factor label. So the subject matter of what I'm talking about is less important than the method. In the question, I state that rhodium, the precious metal rhodium, is $665 per troy ounce. And the question is, if I have $5.15, what is that equivalent to in atoms of rhodium? So this particular type of question, I gave you some other unit conversions as far as 1 troy ounce equals 31 grams, and I gave you Avogadro's number as well. It requires using dimensional analysis. So we're given $5.15 as our starting point. Our answer should have the unit of rhodium atoms. It's a number of atoms. That's what we're looking for. $5 in. Well, we're going from money to number of atoms. So clearly there's going to have to be some unit conversions in here. So the way to read this, $665 per troy ounce of rhodium. So let's go ahead and put that in. $665 is 1 troy ounce of rhodium. We're specifically talking about rhodium, not just any mass. Dollars cancel. My current unit of measure is troy ounces of rhodium. And what I give you in this problem was the fact that 1 troy ounce of rhodium is equal to 31.1 grams of rhodium. We're not done yet. We have rhodium, we have a mass of rhodium, but we specifically wanted the number of atoms of rhodium. And this is where you need to pull out your periodic table and look up the molar mass of rhodium. Rhodium's molar mass, 102.905 grams of rhodium for 1 mole of rhodium. Give myself a little bit more space. Okay, well, what have we accomplished? Grams of rhodium cancel. Now I'm in moles of rhodium. It might feel like I'm going backwards, actually, at this point, because I had a mass, but now I'm in moles. But that's okay, because we have to remember what the definition of Avogadro's number is, what a mole is. 1 mole of rhodium is 6.022 times 10 to the 23rd atoms of rhodium. Moles of rhodium cancel. Now we have atoms of rhodium. This is the unit of measure that we wanted in the first place. So you pick up your calculator, 5.15 times 31.1 times 6.00 to the 23rd divided by 665 divided by 102.905. And this gives me 1.41 times 10 to the 21st rhodium atoms. Three significant figures, so this also has three significant figures. So that works out 1.41 times 10 to the 21st atoms. 1, 2, 3, 4 unit conversions were necessary for us to get our final numerical answer. But it wasn't anything that's impossible. Each one of these conversions by themselves is very, very small, but putting them together, that is the key. And as we go through the semester, this type of problem solving, not necessarily going from money to atoms, but from one thing to another that seems to be very, very far apart, we can do it with dimensional analysis. So if you did not get this problem correct, and I'm looking at you, 3/4 of the class, take the time to rework this problem after you look at this. Don't stare at the answer and rework it. Go off somewhere, rework it with only your periodic table and your calculator. Because if you can do this, you'll be in excellent shape going forward with chemical stoichiometry.